For 840 G2.
Haikuwa G6.
So nini? Nilikuwa nimeiprogram. Hello? 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 I was talking alone. Nilikuwa nadhani nimejoin na comp. Oh. So everything is okay now. Amin uko sawa sasa? Uko sawa? Umeona hiyo mambo ya board number eh? Oh, it's amazing. Sasa kuna ile image niliwatumia. Did you go through the image or the architecture? Was it, leave alone the image and tumatuma. There's that exactly. Mli go through here. Okay. We're having the input section. I think Vincent was having some similar issue, same to this one. Now you have a scenario where I think at this point you know about probably the first and the second MOSFET. Cynthia, let me hope so. We usually have the first MOSFET and the second MOSFET, right? All of you, Vincent, Mohammed, you're all okay with that? Then you know how a MOSFET works, eh? But I did some explanations on it. We had the gate, we had the source, and we had the drain. So what did we say this one is? We have the four which are connected together. What did you say that is? The source? No. Drain. The three connected together, that is the source. Then this one, same to this one, we have these four, we have these three, and we have this one. So we have the source, we have the gate, we have the drain. So how power flows? I was saying a MOSFET acts like a switch. The 4 is the drain, the 3 is the source, 1 is the gate. So this is where all diagnoses zinaanzangia hapa. If you're having any problem with probably missing 19 volts, an issue with the charging motherboard, or an issue that motherboard that is not taking in power, you start with the input circuit, which is usually entailed of the first, second MOSFET, the current sense resistor, and we have the charging IC or the BQ chip or the intercell chip. So we did trace power some time back from the power jack, and we said it goes directly into this first MOSFET, goes into this second MOSFET, goes into this current sense resistor, and are being controlled by a BQ chip or an intercell chip, or this is what is usually called the charging IC, because it manages charging of the battery, that is plus the first and the second MOSFET. So it allows in power or closes MOSFET depending on factors such as whether there is a short or not in the main power rail. When I say power rail, what do I mean by main power rail? Anybody can tell me about main power rail? Yes, Vincent. Yes, yeah, the drain. Okay. I gave an example yesterday with you imagine a scenario where we have a bulb. Tuko sawa mpaka hapo? And I asked yesterday how a switch is usually connected in the electricity. Did Vincent, you said you don't know. Probably have you found out how a switch is usually connected? On a circuit. That switch yenye unatumiaga kufungua bulb ya stima. You know how it's connected? How is it connected? Yes, that wall switch. How is it connected? Yes, how it is connected inside the wires. Okay, we have which and which one? Which represent, we have live, that is negative, positive, and ground, right? Okay, fine. Now give me the connection of how the switch is connected on those three wires. Yes. Oh, okay. Red is the live, black is negative. So how is a switch connected on that circuit? No. No. Explain. Just explain. Yes. What happens? What happens when you connect positive and negative on 250 volts on that steamer? What happens? The positive and the negative zikishikana, what really happens? Inachomeka. That is what happens. Sindio? Now you are saying that you're connecting the positive and the negative so that if you switch on, all right, so how is it connected? Yes, I just want you to get the understanding, because without the basic understanding of electronics, you're not going to understand how this MOSFET works. So, is there a way I can do a drawing? Which application is used to do drawings on laptop? Which one can I use? I think paint works. Let me see. Good. Let me share my screen now. Screen. You're able to see my screen, right? Cindy, my screen is visible. It's blurry. Is it clear now? Okay, fine. Can you see the writings? Can I see what I'm writing? Nimeandika nini? You're seeing halfway. Who else is seeing halfway? Ibrahim, you can see the whole of it, right? It's halfway. Why? It's okay. Why is it halfway? I don't know why. So, I want you to know how a switch is usually connected. The way switches are connected, a switch is, what is the work of a switch first of all? In that circuit, what is the work of a switch? Controls the current flow. How does it control the current flow? Switch. Yes, the bulb switch controls on and off. How does the control of on and off? By connecting and disconnecting the circuit, right? Vincent, I don't know who is using a laptop here. Can you see my whole screen? Thank you. Who is seeing half again? Kama unaona half, weka simu ina landscape mode, eh? Sawa. Now, let's see. Need a thicker brush. Okay, we have this one is live, eh? This is the red, eh? We have this one is live. Can you see it? This one is live. Then we have this one is positive, negative, eh? Then we have this one is earth. Sindio? Now, how a switch is connected? A switch is usually connected like this. Eh? This is the switch. This is the switch. Then we have something like this. Something like this. Sorry. It should be straight. Then it goes like this. So, This is going wherever it is going to, and this one is going wherever it is going to. So a switch is connected on the live, where you get the voltage and the current. Sawa sawa? Tuko sawa mpaka hapo? Vincent, are you listening now? Now, the moment you switch on the switch, what happens? It connects this wire. Now there is flow of current. It connects this wire to this end. Nanielewa mpaka hapo? And when it connects this end to this end, what happens? There is flow of current and the bulbs comes on. And now the circuit is closed or open? The circuit is closed. Your assumption was the switch is connected here, which is wrong. You can't connect a negative positive, because the moment you connect them, what happens is utachoma vitu. Sawa sawa? Now you've understood how a switch is connected, sindio? Good, thank you. Now I just want to brush out. Delete that. Good. So we're having the same scenario here. I just want you to understand this well. We're having same scenario here. We're having this is there is some thick brush. Ni kubwa sana. No. Okay, we're having the same scenario here. We're having, this is the live, where in this case is the 19 volts line. Can you see the screen well? Now, we're having a component here, now in our case called a MOSFET. Sawa sawa? The component has 3 legs, 1, 2, 3. Sindio? The component has a 4th leg, this side, called the gate. This one is called the source. And now the component has 4 legs going out, called the drain. Sawa sawa? These are called the drain. Umeelewa mpaka hapo? Umeelewa? Hope we are okay till there. Ibrahim and Mohammed, are we together? Thank you. Now, these 3, which are the source, are connected to the live we were talking about. Sawa sawa? This drain is going wherever it is going, probably to the second MOSFET, but I want us to understand this concept. Then this gate is going somewhere in what we call the PWM, power with module. Tuko sawa mpaka hapo? Now, so the reason why I was bringing the switch and the bulb thing was for one reason. There must be someone to go and switch on the switch for the bulb to come on. Sindio? There must be someone to switch on and off for the bulb to come on and off. Sawa sawa? Aya, we will call that person Vincent. And here we have Vincent. And here, let's just assume here we have the bulb. Let's assume here we have the bulb, which is connected. And this one positive is a negative, and this is the positive. Just a minute. Hello, hello, ongea haraka, niko kwa class jamani. Talk fast. Bulb, umepata nini? Umepata hiyo sufuria? Is it okay now? Is it okay now? Oh. Sawa. It's okay now? Thank you. Now, we have the 19. This is the main rail. We have the bulb here. We have somebody who switch on and off the circuit for the circuit to work. Remember, inside the motherboard, we don't have somebody who can go and switch on for power to pass through. So these people tried to come up with one intelligent IC that can be doing that instead. So how does a MOSFET work? We have the N channel MOSFET. We have the N channel and the P channel MOSFET. Those are the two types of MOSFETs, the N channel and the P channel. Sawa. Tuko sawa mpaka hapo? Now, let's assume this is an N channel MOSFET. Now, how an N channel MOSFET works is when we have a higher voltage on the gate than the source, power will pass through from the source to the drain. Ume understand mpaka hapo? When we have higher voltage at the gate than the source, power will pass through from the source to the drain. That is the working concept of an N channel MOSFET. When we have a higher voltage at the gate than the source, power will pass through from the source to the drain. Are we okay till there? We are okay, Ibrahim, Mohammed? At the gate, when you have a higher voltage at the gate than the source, when the voltage at the source is higher than the voltage at the, when the voltage at the gate is higher than the voltage at the source, the MOSFET is turned on. That means the voltage passes through the source to the drain. You understood that? to the drain. Iko sawa? Good, you found it. The determinant is what is the determinant? Is the voltage at the gate. Kuna mtu amesema, nani ameongea sahi? Is it Ibrahim or okay? Umesema the main the issue of nimekupata. You were asking a question. We are going to go into that. How or when they decide, it's just their design, how they decide to use an N channel or P channel. Right now we are on N channel MOSFET. I want you to understand how it works first. Yeah, their main choice why they maybe use N channel or P channel is determinant on the manufacturer, of course, on so many other things. But in most cases, in some cases, we have P channel MOSFETs as on the input circuits. Yeah, but in this case, we want to check out on the N channel first. We start with the N channel. So would someone repeat what I said about the N channel? How power flows? Yes, please. Okay. To the bulb, to the drain, either way, yeah? Okay, tuko sawa mpaka hapo? Mtu asiwachwe nyuma. Vincent, you're okay? Sawa. All right. Pardon? Ebu repeat the question. Voltage ikiwa higher at the gate, voltage will pass through from the source to the drain. From the source to the drain, not drain to source. Yes, that is exactly what I am saying. Yeah. So, yes. Hi. Oh, nilipe deni.
Yes. That's correct.
Sema namba. Nini iko sawa kabisa. Kako sawa. This is calling me. 07? Okay, till 30. Ni? 330? 78?
75.
Inatoka 330 7875. Global. Sawa.
Sawa, thank you.
Pole, pole. So voltage at the sources tumesema ni 19, eh? Now the voltage at the gate in most cases is usually around 24 volts. Tuko sawa mpaka hapo? Just cram it. Don't ask a question first. Eh? In most cases is usually 24 volts. Tuko sawa mpaka hapo? Now yes. Voltage at the gate of n-channel MOSFET, mostly, not all, mostly, eh? For that is, for power to pass through the source to the drain, you must get, or you should at least get that 24 volts, which is usually 19 volts plus 6 volts. So the difference between the source and the gate should be 6 volts. Remember I said should, eh? Not must. Should be 6 volts. Again, I'll tell you how that 6 volts comes about. Now, mumelewa, now how the MOSFET works, eh? We have the source. Yes. At the gate, in most cases of n-channel MOSFETs, is usually the source, the source plus 6 volts. That is 19 volts plus 6 volts to get 24 volts. 6 volts, eh? Now, what can I, let me remove this. Yes. No, I'm not removing the whole of it. I'm removing the bulb. When you? Which part? How? Either way, the working principle is same. Yeah, so long as you know that the 3 pins are the source. Even if the MOSFET is looking at this other side, you know that. Okay. We usually have the first dot here. Let's see, brush. Usually have the first dot here. This dot signifies the first pin. Sawa. Then we have the 4th pin. Then we have number 5. Niaje? Uko salama? Mashini moja, ingine ilienda. 11 hii ilichukuliwa, hii kiletwa. Kuna kitu ingine? Pesa ya? 11 hii ilichukuliwa mashini. Ilichukuliwa. Iko duka, mtu alileta hiyo alichukua. Somebody was asking a question. Sorry, I'm getting interrupted. Somebody was asking a question. Yeah, so tulikuwa tumefika wapi? Either way, eh? So we're having these 4 connected together. So from here we have the first MOSFET, eh? Then this 4 now are now connected to the second MOSFET. Now we have the second MOSFET. Okay? The gate again is coming to this PWM chip. Then again we're having 4 which are going out. Remove these extra. Tuko sawa mpaka hapo? Then from here, yes, please. The PWM is to switch on and off these MOSFETs. Yeah, PWM is to switch on and off those MOSFETs. And, pardon? It is a chip. I'm going to show you what that chip is. We are going to learn more about that chip. I really don't know if we have enough time, but we are going to learn. For instance, the chip being used here is what we said, the BQ chip is a PWM chip in this case. I think we'll learn about the famous 24780S, which is about 7 times 4. 7 times 4 is 18. 18 then no, 7 times 4, 1428, which is about a 28-pin chip. We're going to learn about most important chips, pins on it. Sawa. Now, from here, we have the second MOSFET, which is again an N-channel MOSFET. Sawa. From the N-channel MOSFET, we have now the current sense resistor. Iko sawa? Current sense resistor. So then from the current sense resistor, we're having now the main 19 volts. Now this is how a typical input looks like. And now here we have the jack. Here we have the jack where you connect the charger. Now mumeelewa? I unzoom it. There, is it visible? Here is the jack. Here. Oh, can you see it? Can you see it? Can you see the jack here? Yes. The input volts was 19, and now the output is also 19. Somebody might ask himself, why can't they just connect the power jack to the 19 volts directly? Is somebody asking about that? Who can give me an answer on why they had to put in the first, second MOSFET, the PWM and all that, then connect it directly to the 19 volts? Is not? Vincent? You can give out your thought. It's a free You can just give out your thought. Why do you think? Just the same way. Is it Ibrahim or Muhammad who has spoken? Okay. Okay. Now, remember, the motherboard is a very critical thing, eh? And we usually have. From here, we are going to learn. Pardon? Why? Why must we have all these N-channel MOSFET, the PWM, and at the jack we are having 19 volts, then at the output of every other thing here we're having, remember we're having 19 here, eh? Then at the jack we are also having 19. Why do you think we have all these N-channel what switches, a CESR? Why should we have them? Control the power, eh? That's a very amazing answer. So I'll again relate this question to someone, to something, eh? What happens when there is probably nyumba inataka kuchomeka ama kuna waya zimeguzana mahali and we have a main switch just in a house setup? What would be the reason for having that main switch? So that when what happens, something should be done. What could be the main reason of having that? To disconnect current flow when there is a problem. Sindio? So when we are having a problem, it does disconnect the current flow automatically to do what? To protect maybe the circuit or further damage. Sindio? Iko sawa? So that is the reason why we are having all these things. Remember now, I want us to talk about this PWM chip. You may understand this circuit, sindio? Mm-hmm. 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 Yes, yes, yes. Mm-hmm. 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 Okay, first before we proceed, the four pins connected together. Izoni, what are they? Is it the drain? No, you must be sure now. Right now you must be very sure. Mm-hmm. 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 Uh-huh. Is it? Is it different? Mm-hmm. Mm. I have your motherboard. Let me share the screen. This is this is the same. You are using G3. This is also a G3, yeah? So. Okay. I wish I had a multimeter that could be seen. Mhm. It's okay. We'll just go about it. I want us to test some connections. Eh? Yes. You can ask a question. Mm-hmm. They are usually near the power jack. The easiest way is to track the positive line from the power jack all the way. It should be the first MOSFET that is connected on that line. Eh? A minute, just a minute. So, I want us to track this connection. From here, where is it going to? It's coming here. You can hear the beep. You can hear that beep. That means the connection comes directly to this point. Sawa sawa. Aya. Checking on this side, we have no connection. Sawa sawa. That means the power comes from the jack, goes directly onto this first four. Okay, oh, I understand your question. You are asking this diagram is a little bit different. Let me share the screen with this one. Uh, I think you should be understanding the working principle, and you should be understanding the working. I can redraw this diagram to be the exact one on this. I don't know, how can I put it? How can I put it? Okay, let's use this example. In this case, this is different, but it's all the same. Yeah, this is different, but it's all same. Sawa sawa. Now, in this case, we're having a connection at this point. This is directly from the power jack to these 4 pins. Then from here, we have this connection to this second MOSFET. Mnaona? Now, the reason why I'm saying this is different, because we're having the source at this point. What should you call the source? The source is the point of entry of power into the MOSFET. We're having source at this point, then we're having drain at this point, then we're having the gate at this point. Remember, it is now reverse on the second MOSFET. On the second MOSFET, we're having source with the first 3 pins and the drain with the last 4 pins. Can you see the difference? Mnaona tofauti? Yes sir. How are you? I'm doing good. How are you sir? Go inside. Yes, yes. Mmeona the difference? The first one has the first 4 pins are the what? Are the source. You can see, just check from the picture. We're having the first 4 are the source. Power is getting through these 4, getting out through these 3, are controlled using this one. On the second MOSFET, power is getting through through the first 3. Then we have the gate at this point. Then we have the drain at this point. So what I want you to understand is the working principle. Mmeona tofauti? You are being convinced? Things, everything, on these motherboards, I don't want you to be so much rigid. Be open to some very little changes. Remember, the same thing, we have thousands and thousands of laptop motherboards. And whoever determines how is going to do the manufacturing is the manufacturer of that single motherboard. Sawa sawa. So 90% of those laptop motherboards have this architecture. So if you see me teach you this architecture, this is an architecture in a lot of those motherboards. Hi. Yes, yes. Ask your question. The gate. Now, in either way, in all those ways, the gate is usually on its own. Look at this track. These 3 tracks are connected together. Sindio? I don't know if you can see. This one. Sindio? You can see that? Yes, in this case, the drain. In this case, this is the drain. They are all connected together. Sindio? Then kuna kamtu kamebaki peke yake hapa. So that is the guy. Yeah. Any other question? Mm-hmm. 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 Same line. Mm-hmm. This diagram, let me this diagram. Mm-hmm. You're having a question. Mm-hmm. Yes, that is true. To the motherboard, Yes. Yes, yes, I'm seeing it. Mm-hmm. I think, yes, I think that is what Vincent was trying to ask. And that is why I was saying that the manufacturer will decide on what type of MOSFETs they are going to use. This manufacturer decided to use a MOSFET with I think you are the one who asked me about what if the MOSFET is reversed. You asked me something of that kind. Oh. So in this case, it is, but the working principle is one. We're having the gate, we're having the, in this case, this is the drain. This is the source. Sorry, this is the drain. Then we're having the source. We shikilia tu kwa kichwa that the source is the point at which power gets in inside the MOSFET. Then the drain is the point at which power gets out from the MOSFET. Then wherever the place we will be having a gate. Then also remember, this is just the most popular type of MOSFET used on laptop motherboards. Most of the MOSFETs, and if you're doing anything related to electronics but not dealing with motherboards, you will see MOSFETs that looks like this, three-legged MOSFETs. Or you will see MOSFETs. There is a machine I was working on some time back. Let me see if I'm still having that MOSFET. Let me see. So, I want you to be learning a lot. If we speak good, I'm having that MOSFET. There's a time I was working on, remember I get several boards. I was working on a motherboard for the, is it X-ray machine? A certain X-ray machine. Oh my goodness, it's so big. Iko kubwa sana. Okay. We have a MOSFET that looks like this. It's so big. It's so huge. Let's see. Good. It's visible. This is a MOSFET. Hii ni MOSFET. Same working principle. Either way, you must find three lines. A gate must be somewhere here, a drain must be somewhere here, and a source must be somewhere here. So either some two lines are connected together to represent maybe a drain or a source, and one gate is somewhere. Sawa sawa. We have several other types of MOSFETs, but they have one and the same working principle. We have the gate, we have the source, we have the drain. And most of them are used like as a switch. Sawa sawa. Mm-hmm. Mm-hmm. Is the drain. Then the guy, that's how you identify? Yes. Any other question? Do you have any other question? Sawa. Now, yes. Mm-hmm. Where the gate is. Uh, there is a way, but it doesn't make sense if I don't know. Can you see this picture well? Let me continue zooming it up. I was testing for continuity to see where there is a connection from the power jack, just to determine where there is continuity from the power jack. On the yeah. I think I'm going to I'm going to find a way of giving you some assignments to make you train how to use the multimeters, and probably you can see something that we've learned, like in this case the MOSFET. You will visually just see it. So how will you visually just see the gate? We have kuna hii track, unaona kitu ya blue, this blue thing, can you see it? This blue thing, you can see it well. Now this is what we call a track. A track is just a wire doing connection on the motherboard. The moment you see that this track is connecting this point, this point, this point, in this point, the 4 points, like in this case, you just know that there is no gate there. Go to the other side. You'll find 3 tracks are connected together. You see this blue thing going this way and connecting these 3, but leaving out this one. You can see it, You can see it well. So at that point, I hope I'm not alone. Good. At this point, you know that this is the gate and this is the drain. This is the source of the drain or whatever, right? Same to this point. This loner huu mwenye anakanga amekaa peke yake, this is the gate. Unaona yako peke yake, hawa wako connected, 4 of them. These 3 are connected. Then this one is connected on its own. So these are the source of the drain. Then we usually have the gate here. Is that okay till there? Are we okay? Tuko sawa? Do you have any other question about the MOSFETs? How do you test whether a MOSFET is shorted or not? When you want to test whether a MOSFET is shorted or not, you switch your multimeter to beeping mode. After switching your multimeter to beeping mode, you check this side and this side. If you hear a beep, that MOSFET is shorted. This side to this side, drain to the source. Sawa sawa. If you hear a beep, then that MOSFET is shorted. Sawa sawa. How to test for a shorted MOSFET? If you connect the drain to the source, the 2 probes, these are the 2 probes, black and the red. You connect the one side continuity mode. Continuity mode ni ile ina beep. Sawa. Continuity mode ni ile ina beep. So when you connect one side and one side and you hear it beep, then you just know that the MOSFET is shorted. This side and this side, when you hear a beep like this, then you know it's shorted. Otherwise, it should always remain like that. So on one side, yeah, on the drain and the source. On the parallel, I didn't understand. What if? Either way, because all those pins are connected together, so that should not worry you. On any pin on the source, they are connected together always. All those pins, the 4 pins are connected together and the 3 pins are connected together. So even if you put it on the first pin or the second pin or the third on the fourth, and here you put it on the first, on the second, or the third, any of these pins and any of these 3 pins like that. So any question? Any other question? Yes. Ibrahim? Ibrahim, you've raised your hand. Yes, I can hear you. Of a dual MOSFET, we'll learn about that. A dual MOSFET is 2 MOSFETs combined in one. Two MOSFET. The working principle is the same. The working principle is, so you just imagine that this MOSFET and this MOSFET have been combined together. What happens if they are combined together in one chip? What would you imagine? Imagine we having one big chip combining all these two. Number one, we will have 2 gates. Sindio? They will be having one gate for one MOSFET inside that chip and another gate inside the MOSFET in that one chip. Sindio? The second thing, we might have separate drain and source in some cases. But in some cases, we might just have one drain and one source for the whole chip. Sawa. I don't know if we are having a dual MOSFET here. Hatuwezi kosa dual MOSFET on this. Dual MOSFET is just 2 MOSFETs combined together. Let me see if I'll get a dual MOSFET. I think it is usually in the 840G3. Good. We are having a dual MOSFET here. How do you determine a dual MOSFET? A dual MOSFET will have 2 gates. Nanielewa? A dual MOSFET is now 2 MOSFETs combined in one. We're having this one. We're having a gate here. We're having a gate here. We're having probably the source here and the drain here. Have you seen it? Either way, how you test it is still the same. Drain and the source in continuity mode like this. If it beeps, shorted. If it doesn't beep, it's okay. Any other question? Can we finish at 8 today? Yes. Mm-hmm. The source and the drain can be anywhere. Yeah. In this case, for me, I would clearly know where the drain is and where the source is. How would I know that? I know I have a background knowledge that when I see a coil, it stores energy, and the coil is usually connected on the output of the MOSFET. I'll come with my beeping mode, connect one to the coil here, connect here, I hear it beep, come this side, connect it, it does not beep. Now I know there is a connection from here to here. What conclusion do I make? When there's a connection from here to here, then this one will be the source and this one will be the drain. Nimewachanganyisha ama? Umeelewa? Vincent, you are raising your hand. Mm-hmm. Okay. Okay. Mm-hmm. Mm. Mm. Just from there, you should not just decide that, you know what, I'm doing the recording as well on today's class. I think it's about 1 hour 17 minutes. Ndio inamaliza. I'm going to send it. Any other question? Any other question? Mm-hmm.